Okay, the first thing I want to talk about was this was in the slides, um, where if you are only using the referrer field to do the access control, and you're assuming that the source of the referrer field, so for example, this URL is protected, then if all you're doing is checking for the URL in the referrer field, you can fake it. So that's what this piece of code does. I don't think the only thing is, so this is the thing that's being protected, and this is the only access control on it, and that's a no-no. So that's that lab. I'm not going to walk through it because it's pretty simple. The next lab that I want to talk about is, let me see here. This particular lab is where the access control is being done on the URL itself, and based on where the URL is pointing to, it'll deny it. So for example, there are a lot of websites that are organized in multiple tiers where you have a front-end dispatcher that will then actually reverse proxy your web request to a back-end private server. And we just talked about how web application firewalls can be used to basically proxy the connection, terminate the connection and look at what's being sent. And then, for example, the file path traversal vulnerability, if the web application firewall sees that that's being traversed, it'll basically drop the connection immediately. Now, if you have implemented this where you have a reverse proxy tier before you actually go to the actual web server, one of the things that happens is that this reverse proxy will often, as part of its functionality, will need to rewrite the URL to hit where the actual destination is. So for example, if your private web server is got these private IP addresses that it uses to implement these URLs on the reverse proxy, then basically what's happening is the URL request is being rewritten, and there is this header. When this happens, there is a header that says, oh, the original URL that the user sent to me was whatever, /admin. And so the problem with the validation based on just URL access is that the X original URL, if you're using just this to do the access control, this header can be faked. And that's the idea of this particular level. So in this case, if you validate just the URL itself, and not both the URL and the X original URL, this is where the access control can get broken. And so for this particular lab, and this is why I'm covering it, this is quite confusing why this actually exists. So that is, let me see here. So I want to bring up this lab where it's the URL based control can be circumvented and show you the functionality here. And in order to do that, I need to log in. Sorry, I should have done this ahead of time. Oh, and I have to turn on my password manager. Sorry. Do I need, all right. Okay, so in this case, I'm accessing it as a normal user. And then what I'll do is I'll inspect this link. And if you look at this link, it's the /admin panel. And the website operator has made it so that it doesn't matter if you're an admin or not. If you try and click this link, you're going to get access denied. Actually, I wanted the developer tools up on this thing. And so you can see this thing gets a 403. I think that's all I wanted to show you. So the way you can probe whether or not the backend, like whether or not there's 3 tiers that implement this website, is to see if you can send the X original URL header and to make it different than the actual header that the actual URL that you're accessing. So the idea is that if I access slash, but then in the X original URL, use /admin. What the backend needs to do is validate that neither one points to /admin. If the backend is only looking at the beginning or is only looking at one or the other, this is where the confusion happens that allows you to bypass the URL-based access control. Okay, so that leads me to the program and how it might be used to circumvent this. And so in this case, I have a site. So this is whatever your site is. And then what you want to do is, and I'll do this first. So the first thing is I'm going to try and directly access /admin, just like I did in the browser, and then get this response code back. So this is what I'll do here. I'll just copy and paste this onto the site. And then you can see over here on the console. Whoa. So it's just going to try and direct access to /admin, and it says access denied, just like we saw before. And so now we're going to tamper with the actual header itself. And so what we're going to do is we're going to say, you know what, I actually wanted the main site, but when you do the X original URL, I'm going to see if the backend is going to allow me access to /admin. So in this case, the front end might be looking to filter all of the regular URLs, but because it didn't check this, when it gets forwarded to the backend is going to allow this access to /admin. So that's the confusion vulnerability. What the front end needed to do is to validate both of these things. Not only that they matched, that neither one had /admin, and then forwarded on to the backend. And that would have solved this particular vulnerability. So when you're talking about a prevention mechanism, that's what you would write to do this validation consistently on the front end. And so this is the level where you're accessing this. And so the headers, this is the actual HTTP header that you're specifying. And you can just specify this as a dictionary, a Python dictionary, and then it will just get added automatically on your access. So that's basically what this is doing. And so let me run this again. And then the access denied. And then this is if you have that header set. And then if you look at this, you can see that you are now the admin here. You actually have the admin panel. Okay, so that's that level. And it needs a little bit of explanation. Otherwise, it's kind of like a mechanical level unless you actually see why this thing actually exists, is the idea. Okay, the next thing I want to talk about is a level where you can use JSON to upload arbitrary entries in the backend database that specifies the user's role. And I wanted to show you this code because the previous form submissions were done using the standard www URL encoded mechanism. In this particular case, the form submission is done via JSON using JavaScript. And I wanted to show you when you reverse engineer the site, how the form submission is done, and then what the equivalent is in Python. So that's what I'm going to do next. I'm going to bring up this level. Dang, I should have done this ahead of, oh no, it would have expired. Okay, so I'll go to my account, and then I'm going to inspect this page, and then I'll. Okay, so if you look at this page and you look at the login form, you'll see that the post goes to /login. Wait, is I on the right page? Hang on a second. Yes. So actually, I'm going to log in. So after I have logged in, you're basically going to look at the update email submission. So if I inspect this, you'll see that this update email form, if you look at this, this is the form. And it says on submit, you're going to say JSON, you're going to call a function called JSON submit. And you're going to submit this form data to /myaccount/change email. And so you'll see a file here, a JavaScript file that implements the JavaScript for doing this form submission. And so what I'll do here is I'll right click this and I'll reveal this in the sources panel. And so this is the JavaScript code that does the form submission. And if you could debug this in the JavaScript debugger, but what I want to do is just quickly walk through what this code does. You can see that it collects all of the key value pairs for the form. So it gets access to the form element in the DOM, gets all the key value pairs, and then it does this. So it creates it basically is a JSON object is what it's creating here, because this is basically JavaScript dictionary. Or, well, it's the equivalent of a Python dictionary in JavaScript, the JavaScript object. And then what it does is it takes that object and it calls the JSON stringify. And so this is where the interaction with this particular form is done with JSON submission rather than in the login form, where that is done using the regular standard form submission. And that's what I wanted to show you. And so when you see that this AJAX request, the XML HTTP request is being done, it posts the payload onto that path that you have given it. And it's basically going to send the JSON data as the form submission for that form. Okay, so one of the things with this JSON is that typically you are assuming that the only key that is being set is the email, right? But as it turns out, if the server takes this JSON and uses any of the fields to basically insert into the backend database, what happens is you can inject arbitrary JSON, arbitrary fields in your JSON that might give you elevated privileges on the backend. And that's basically what the vulnerability is when you're updating the email, you specify, rather than role ID of 1, role ID of admin or 2, or I forget what integer it is. And so in order to actually pull off the exploit, you basically have to submit a JSON object that's got the rogue fields in it. And that's basically what I want to show you in the code. And so so actually, yeah, I actually have this here where the role ID is oh, actually, you're given role ID of 2, and then you change it to 1. And so what I do is I basically have this JSON data. And so if you submit the change email form and you do you do it faithfully, what happens is you'll be sending this JSON data. So again, this is a dictionary in Python. But when I call this post with the JSON keyword and point it to this JSON data, what this does is it'll take the dictionary and then convert it into a JSON object that's equivalent. And then you'll see that you'll get the original change email. And so you can then submit arbitrary JSON. And this is the vulnerability of this particular level. Okay, and then that would then, if you change the role ID of your account, then you'll be able to basically finish the level. Okay, so that's it. Sorry I went so far over. I will see everyone next class.